will discuss about ionic radius. What is meant by ionic radius? Ionic radius, it is nothing but radius of an ion. Ionic radius is nothing but radius of an ion. So ion may be cation or anion. Ion may be cation or anion. So here how the cation is formed and how anion is formed. For example, from this atom, if we remove one electron, so here A will become A plus. So here it is a cation. And to the atom, if we add one electron, that will become anion. Okay, so here we are talking about ionic radius. Ionic radius is nothing but radius of an ion. So ion may be cation or anion. So how cation is formed? Here from any atom, if we remove one electron, we will get a cation. So if we add one electron, anion is formed. Now, in generally, it was assumed that ionic radii of anion is greater than its parent atom, and here ionic radii of a cation is lesser than its parent atom. So here the general trend will be here ionic radii. This is ionic radii. This point you have to remember. And here ionic radii, it was assumed that ionic radii of anion is greater than its parent atom and the ionic radii of cation is lesser than its parent atom. Now we'll discuss first how this ionic radii of anion is greater than its parent atom. So for example, here how the anion is formed, here we have added one electron. So here for example, let us take this this atom, and here in this atom, it consists of, for example, 4 electrons, just assume. So here we have added another electron. So this is the electron added to this. This is the parent atom, you assume. To this parent atom, if we add another electron, so that will be here. So here we are adding one more electron to this atom. There will be a repulsion between these electrons and the nuclear charge is same. So to avoid that repulsions, here they move far apart and the nuclear attraction between this nuclear charge and the electron also decreases. So what happens to the size? Size increases. So if you compare the parent atom and the anion, and the anion is having high ionic radii when compared to its parent atom. Why? Because just listen to me. Here when the electron is added to any atom, see here the nuclear charge is same, but additionally one electron is coming. So there exists an electron repulsions. So because of the nuclear charge is same, so because of the electron repulsions, there is an increase in the size. Attraction between the nuclear charge and the electrons decreases, there is an increase in the size. This is how we can justify ionic radii of the anion is greater than its parent atom. Now, how the ionic radii of the cation is lesser than its parent atom. So, for example, how the cation is formed, same this system. So, here it is a parent atom. Same, you assume it has 4 electrons. 1, 2, 3, 4. And here from this, we are removing one electron. So, what happens? Same nuclear charge, we have removed one electron. So here there will be an increase in the attraction between the nuclear charge and these 3 electrons. So it will attract the electrons towards itself. Ionic radii of cation decreases. Ionic radii of cation is lesser than its parent atom. This is how ionic radius of anion is greater than its parent atom and the cation is lesser than its parent atom. So ionic radius, radius of an ion may be cation and anion. Here I have explained how the cation and anion are formed. If we remove one electron from any atom, the formation of a cation, and here if we add any electron, we'll get anion. Okay, so now we'll discuss some of the questions based on this ionic radii. Arrange the following in increasing or decreasing order of their ionic radii. So here if you observe the question number 1, here it is anion and it is a parent atom and it is a cation. So I told you already, ionic radii of anion is greater than its parent atom, ionic radii of cation is lesser than its parent atom. Okay, simply here also ionic radii of anion is greater than ionic radii of its parent atom. So if you observe this, here on the oxygen it is -2 and in this oxygen it is -1. So here 2 electrons are added in this one and 1 electron is added. So 2 electrons are added, more repulsion when compared to the addition of 1 electron. When more repulsion is there, more increase in the ionic radii, because nuclear charge is same and the electrons are increasing. So here there is an increase in the ionic radii. So here the anion with the higher charge is having, anion with higher charge, he is having higher ionic radii when compared to the anion with a lesser charge. So if you observe this one here, anion is having a higher ionic radii than its parent atom, and this is order will be same. And next if you observe this cation. So here what happens to the cation? Cation, how the cation is formed? Here removal of electrons leads to the formation of cation, because it's here electrons are lost, no? So positive sign. Deficiency, positive sign. So here the chromium 3 plus and chromium 6 plus. If you observe these two, here loss of 3 electrons, here loss of 6 electrons. So here loss of 3 electrons means here if you observe loss of 6 electrons and the nuclear charge is same, so the attraction between the nucleus and the remaining electrons increases, so ionic radii decreases. So here this chromium 6 plus is having less ionic radius when compared to chromium 3 plus, because here I think you got this point. Here loss of 3 electrons and loss of 6 electrons. Here more electrons are lost. Here there is an increase in the attraction between the nucleus and the remaining electrons. So it attracts the electrons towards itself, the nucleus. So the cation with the higher charge, the cation with the higher charge is having lesser ionic radii when compared to the cation with a smaller charge. And here the anion with the higher charge is having more ionic radii. You can note this point. And cation with higher charge is having less ionic radii. So here if you observe Fe2 plus and Fe3 plus, this is having less ionic radii when compared to this one. And similarly Mn2 plus, Mn4 plus and Mn6 plus. This will be the order. So this is how you can predict the ionic radii of these species, cations and the anions. Okay.